Let's look at the page 622, problem 42. And we multiply this to complex numbers in this track form and write answer in the form a plus bi. So this is the page 622, problem 42. We have root of 3 times cosine of the 45 degrees plus I times sine 45 degrees and times root of 2 times cosine of the 315 degrees plus I times sine 315 degrees. So right now, these two complex numbers are in the trigonometric form. So by the formula, we just need to multiply the moduli and then add the arguments. So now you multiply this root of 3 and root of 2. You have the root of 3 times 2 by the product rule for the radicals. And then for this part, you add the arguments. So you have the cosine of the 45 degrees plus 315 degrees and plus I times sine of 45 degrees plus 315 degrees. Then simplify, you have the root of 6. So 45 degrees plus 315 is equal to 360 degrees. And so you have the cosine of the 360 degrees plus I times sine 360 degrees. What is a cosine 360 degrees? 1 or 0? It's 1, right? So 360 degrees is the period of the cosine and the sine function. So you can throw it away. So actually this is same as the cosine 0. Cosine 0 is equal to 1. And the sine 360 degrees equal to what? 0, right? This time is 0. So you have the 1 plus 0, 1 times root of 6. So that is a root of 6. Now let's look at the problem 47. And we try to divide this to complex numbers. So page 622, 47, we have 4 times cosine of the pi over 3 plus I times sine of the pi over 3 over 2 times cosine of the pi over 6 plus I times sine of the pi over 6. So for two complex numbers in the trigonometric form, to find their quotient, you may just divide their moduli and then subtract the arguments, right? So right now this 4 divided by 2, you got a 2. So let me put a 2 here. And actually we don't need this division bar. So 4 divided by 2, you got 2. And then times cosine of the difference of their arguments. So you have the pi over 3 minus pi over 6 and plus I times sine of the pi over 3 minus pi over 6. So pi over 3, this is same as the 2 pi over 6, right? And then minus the pi over 6 plus I times sine of the 2 pi over 6 minus the pi over 6. Finally, you have the 2 times cosine of the 2 pi minus pi, you have pi over 6 plus I times sine of the pi over 6. And we need to get the result in the form a plus bi. So let's evaluate this cosine and sine. And cosine of the pi over 6 is equal to root of 3 over 2 plus I times sine of the pi over 6 equal to 1/2. Now you multiply each term by 2, get root of 3 plus I. Now let's look at the 54. Find the z1 times z2 and the z1 divided by z2 for each pair of the complex numbers using the trigonometric form, and then finally write the answer in the form a plus bi. So right now, this z1 and z2 are not in the trigonometric form. So that means first we need to convert these two complex numbers to the trigonometric form and then apply the formula, then get the result, and then write the result in the form a plus bi. So this is the page 622, problem 54. We have the z1 equal to negative square root of 3 plus I, and z2 equal to 4 times root of 3 minus 4i. So for z1, let's first get its modulus. R1 is equal to the square root of the square of the negative root of 3 plus 1 square, right? The coefficient of this I is equal to 1. And this is equal to square root of the 3 plus 1. So that is a square root of 4. So it's equal to 2. And then let's get the argument of this complex number. So cosine theta 1 is equal to this real part, negative root of 3 over 2. So let's first get the arc cosine of negative root of 3 over 2. What is the value for this? What is that value? If we don't have this negative sign, we know arc cosine of the root of 3 over 2 is just equal to pi over 6, right? And then if we have this negative sign, then that should be the pi minus the pi over 6. So this is the 5 pi over 6. So actually, draw the sketch. So this is the pi over 6. Right. And then this guy is the 5 pi over 6. So in the interval from the 0 to pi, only the 5 pi over 6 for which the cosine is equal to negative root of 3 over 2. And actually, we can also plot this complex number in this complex plane, so it's also in this quadrant too, right? So that means the 5 pi over 6 is the argument of this first complex number. So we have the theta 1 equal to this 5 pi over 6. So now we can rewrite this z1 in the trigonometric form. So that is the modulus 2 times cosine of 5 pi over 6 and plus I times sine of the 5 pi over 6.